Let's talk about assessing risk. Looking at this graph, is driving getting safer? So, in 1970, there were this many deaths. We're going to say that's 52,100 deaths. And out of how many miles driven? So the miles driven right here would be 1.1 times 10 to the 12th. I don't expect you to be able to read that, okay? But that would give you 4.7 times 10 to the negative 8 deaths per mile. In 2011, there were less deaths. We'll say 32,000. And the amount of miles driven was more. 2.9 times 10 to the 12. So 1.1 times 10 to the negative 8 deaths per mile. So comparing this objectively, yes, we can conclude that over this period, the death rate has dropped per 100 million miles. So we conclude the death rate per 100 million miles dropped. That's a good thing. Assuming a U.S. population of 315 million, find and interpret risks per person and per 100,000 people for accidents and suicide. Okay, so accidents are here. So there were 122,800 deaths caused by an accident out of 315 million people. That's 0.00039 deaths per person. But that's not a very helpful way of looking at it. Okay, you can't have such a small fraction of deaths for each person. That doesn't make sense. So we take that number and we put it in context of 100,000 people. So there were 39 deaths per 100,000 people. That makes sense. Out of 100,000 people, there were about 39 deaths. And then for suicide, 38,300. Out of 315 million people. 0.00012 deaths per person. So again, we'll multiply that by 100,000 and get 12 deaths per 100,000 people were caused by suicide. Life expectancy is the number of additional years on a person of a given age today can expect to live on average. Using the figures shown, find the life expectancies of a 20-year-old person and a 60-year-old person. Are the numbers consistent? So at 20, we find that correlates with 60. So a 20-year-old can expect to live 60 more years, or 80 years. A 60-year-old we'll say that's 23, can expect to live 23 more years, so to about 83 years of age. Why is it different? Well, here's the thing. If you're 60, you've already gotten to 60. So the chance of you living longer is better because you've already gotten there. Makes sense? I hope. Example 4, using the figure, determine how much life expectancies rose during the 20th century. Suppose that life expectancies rise by the same amount during this century. What will life expectancies be at birth for children born in the year 2100? And what are the implications for your own life? Oh, got to go back to the graph. So, in the past 100 years, life expectancies for women rose from about 48 years to about 80. So 32 years. For men, life expectancy has increased from about 46 years to about 74, or 28 years. So if it continues this way, women right now are living to be 80. If we add 32 years to that, then that means in 100 years, women could expect to live to be 112 years old. I don't know if I'd want that. And men right now live to 74. If it continues growing at the same rate, they could expect to live to be 102. So note that although this example deals with life expectancy at birth, life expectancies for all ages tend to rise together with time, so that the elderly people in 2100 will be living to ages similar to those indicated by the life expectancy of newborns, so about the same. Therefore, if life expectancies continue to trend from the 20th century, there's a good chance that today's high school and college students, that's you guys, will live to average ages over 100 for men and 110 for women.